going to display.
The performance-ready interactive digital instrument.
It is a board where you roll balls and the balls make noise. Physically, it consists of a walled table with the base, with the surface of which is a pegboard, so that you can put on these blocks that stop the balls, and a mic stand with a camera and a light. The table has no electronics on it. This is entirely removable. In theory, you could put this on any table that is black, and with these QR codes allow the camera to pick up what surface you're using. The box is connected to the camera and the computer. It has an Arduino inside. The switches control the continuous nature of each color of ball.
Either continuous or discrete.
Continuous just means whereas with discrete it's playing individual notes in a scale.
The idea that we had was we grouped balls by palettes of colors. So we have blue, green, and brown all on a palette. And we have, yellow, red, and orange on a palette. You can build a sound profile for a palette, and then you can turn the knob to select what sound profile you're assigning to that palette.
And the last knob here controls what scale you're playing, a major scale and then a harmonic minor.
Our main sensor here is a camera. It picks up these balls. You can see here on the left is the original image, picking up the QR codes. Then we put it through these color masks, so if you throw them over it, you put your hand over it, you do fun stuff like that. It says, this is the color that we think that entity on the board is. The computer says, oh, that looks kind of like a circle. I'm going to guess that's a circle. Then we have a notion of what balls are actually on the board. And once you have that, you have all this fun data about the state of moving objects that you can map to things like music.
A big part of being able to do that was we wrote a lot of the code for this in Python. We can say, like, okay, we know where a ball was last frame, and then this frame we see balls here. What ball was it? And we can infer things that way.
We realized that if we sent all the data as fast as we could, it overloads Reason. Blue ball colliding with the side there. You can also just play this in three-dimensional space if you want, which is fun. But that's a collision with the side, collisions with balls, sound like that.
So computers have a different notion of color than we do, where you have these color spaces which are parameterized by different levels of different values. So like when he said RGB, that's red, green, blue, and it's just mixing different amounts of adding red, adding green, or adding blue. HSV is just a different one of those color spaces that works a little bit better for what we're trying to do. And we didn't quite figure out how to optimize what color balls we need for spreading them out evenly over HSV color space and figuring out how to get those masks so that they're easily differentiable.
This only works with consistent lighting. So we had set up this flashlight here, hit the light.
Yeah.
So this changes the color of the board, so all of the color masks don't work, but it's a feature.
Another problem we ran into is in the first iteration of this, it was just wood and we didn't have it painted, and we were like, oh, you know what makes colors more easily detectable is if they're on a black surface. So we painted it black, and it just didn't work anymore. This camera has auto exposure on. If you're shining it on a black surface, it says, whoa, you're in a dark room, let's help you out with that. But we didn't want that.
Because we weren't in a dark room. So our solution to that was we found this package online called UVCC, which is like a universal video control configuration tool, and basically we wrote a shell script in Python. It turns off auto exposure automatically and then sets the exposure to an exposure that we think is good.
Their Python code is giving the Max patch these continuous packets of
open sound control messages, which is just easier to do between Python and Max.
Yep.
And it's also a language Max speaks very well.
First specifying what palette we're on, and then the actual shade of the ball. So like for example, blue is palette 1, shade 1, green is palette 1, shade 2. And then we're getting an action, and that's defined by note 1 means note on, 2 means note off, 3 means pitch bends. That just sent a note on, and then a bunch of pitch bend, and then a note off once it falls out of the range. The max patch is built on this architecture of taking apart that packet I receive from these guys one step at a time. So here we're splitting based on palette or column, and then on the individual color in that column, and then here's the actual note creation, and inside here we have a switch for changing what key, and basically banks of scales. And the reason patch is built of a bunch of combinators. Some of the ideas behind the sounds are blue and green are meant for like melodic playing. Red is are always like pre-built sequences. Familiar. Orange and yellow are just, they're like bass, and then like extra like tweaky sounds, and then brown is like ethereal, like ambient sounds. Yeah. This is a side collision, and a 4 means a ball collision, and those each trigger different sounds.
Turn it on sometimes. Alright, go ahead.
What's that?
Or are they all on?